So we spent a lot of time reviewing factoring, and now what we're going to do is we're going to solve quadratic equations by factoring. And so we're going to utilize the skills that we learned before on how to factor the equations, and then we're going to go and take it one step further to actually solve. So when you solve by factoring, we're talking about, again, we're solving quadratics. And when I say that we're solving quadratics, what I mean by solving quadratics, right, is I'm solving equations that have x to the second power in it, okay? So up until now, we've been focusing on linear equations. Linear equations have like 3x plus 2 equals 10. And basically on these, what you do is you isolate the variable. You get the variables and the numbers on opposite sides. We get 3x equals 8. You divide by 3 and you get x equals 8/3. And you usually get one solution. We learned that they're not all one solutions in linear equations. Sometimes there's no solution, and sometimes there's all real numbers or infinitely many or infinity. But again, notice that those were linear equations, and what makes them linear is the x is to the first power, so first degree. In quadratic equations, the x, or the variable, is to the second power, okay? And so there's going to be a few differences here. Now, what's going to happen here is when you solve it, you're oftentimes going to get two solutions, okay? And so those two solutions also mean something in regards to the graph. When we graph a quadratic equation, it usually is, it's always in the shape of a parabola, and it usually crosses the x-axis in 2 points, okay? And when it crosses the x-axis at 2 points, you're going to have an this coordinate is going to be xy, right? But if it's crossing the x-axis, let's say it's going to be x and a 0. And the other one is going to be a different x, but it's still going to be a y value of 0 because, again, the y value is 0 at the x-axis. And so what we're solving for are these x values, okay? When we solve a quadratic equation, what we're finding is the x-intercepts. We're finding the spots on the graph where the graph crosses the x-axis. And so sometimes you're going to have two solutions because your graph is going to cross in two places. Sometimes you're going to have one solution because your graph is going to just have one point on the x-axis. And sometimes you're actually going to have no solutions because your graph is not going to cross the x-axis at all, okay? And so what this would be is, this is what we call no real solutions. And we'll talk about that more. But so quadratics will either have one solution, two solutions, okay, or no solutions. Now, most of them have two solutions, okay? And so that's kind of interesting too. It's a little different from linear, which usually has just one solution. And another difference between quadratic and linear is that in linear, like I said, remember that you're getting the variable on one side and the numbers on the other. However, in a quadratic, what you're doing is you're getting all the terms on one side and you're setting the equation equal to 0. So what you're doing is you're trying to find the x values that make the equation equal to 0. And so once you set it equal to 0, you're going to factor the equation and you're going to find the variable values that make it equal to 0. And again, I'll show you. So let's do an example of one. So when we get here to number 1, we're going to actually factor number 1. And so we realize, oh, this is a difference of squares. What this is x plus 1 times x minus 1. And so right now we have two factors and the product of those factors equals 0. Well, there's a property called the zero product property that says if you multiply anything by 0, the entire product is 0. So if this factor here equals 0, the whole thing equals 0. If this one equals 0, the whole thing equals 0 as well. And so what happens is, how we solve then is we basically say, okay, well, what values of x plus 1 will make it equal to 0? Well, if I solve it, I know that -1 will make this expression equal to 0. And if I set the other factor equal to 0 and do the same thing, I'm going to see that if x is 1, the factor equals 0 and the whole product. So this has two solutions. In other words, these are the two values, x equals 1 and negative 1. These are the two values that will make this equation equal to 0. And so on a graph, just so you know, these can become ordered pairs. It's like 1, 0 and negative 1, 0. And so I know that at negative 1, 0 and 1, 0, my parabola is going to cross the x-axis. So it's going to look something like that, okay? So again, know that the solutions of a quadratic equation are also the x-intercepts of the graph. Now, I'm not going to draw the graph every time. We're going to do a chapter on graphing. I don't need to do this every time, but that's just something I want you to kind of think about. So again, here, we always do the same thing. We move all the variables to the left, we make n numbers, and we make it equal to 0. Here, notice that I only have the x squared and the x, so this is a binomial, and I can factor out my GCF. So I get 3x plus 1 equals 0, and so again, I set each factor that has a variable equal to 0. So this one here is x equals 0, one solution. And then this one here is 3x plus 1 equals 0. Again, I'm going to subtract the 1 from both sides, and I'm going to divide both sides by 3. And I'm going to get that x is negative 1/3. Okay, so we see again in number 2 that we have two solutions. And notice I'm not checking for extraneous like we were in previous slides, because remember, the extraneous solutions came in when we happen to have denominators with variables in it. Since we don't have that scenario here, we're not really looking for extraneous. Now we get to number 3, and a tricky part here is that a lot of people want to start solving as is. You know, they might say, oh, let me just divide both sides by x, and I'll get, oh, x equals 1, and I get one answer. But that's not how you solve quadratics, okay? When you have this scenario, remember, you have to set the equation equal to 0 to be able to solve. And so it's x squared minus x equals 0. Now you have two terms, so you know this is a binomial. You're going to factor out your GCF, and you're going to get that x equals 0. You set this one equal to 0, and you set the x minus 1 equals 0, and you get x is 1. So notice that if you had not set it equal to 0, you would have only had one of the two solutions for this problem. You would have come up short. So again, remember, move the x over, set it equal to 0, and find your answers. Last one. Now, notice this is a trinomial. We're going to factor this using the traditional method. I know my product has to be -8, and my sum has to be +2. And so I know that this is x plus 4 and x minus 2. So at this point, I know that I have to set each factor equal to 0 and figure out, well, what number is going to make, what variable value is going to make this equal to 0? Well, -4. Then you do the same thing here. X minus 2 equals 0, so x is 2. And so these are my two solutions for this problem. Both -4 and 2 make the equation equal to 0. And again, how this translates is on a graph, I know that my parabola is going to cross the x-axis at -4, 0 and 2, 0. If I go to this page again here, this page is full of, it has a couple trinomials here at first. So again, I'm going to do the traditional. And with trinomials, you're still going to try to factor out a GCF and do everything that you've been doing up until now, right? Again, this product I know has to be -30. My sum has to be -x. So it's -6 and 5. So remember, I take the first term and leave it. The middle term changes to -6x plus 5x, and the last term stays the same. And then I factor the GCF of my first term, x minus 3. I take the GCF out of the second term. That gives me x minus 3. And I know that x minus 3 is one factor and 2x plus 5 is the other. And it equals 0. So I had to do a little work to factor. Once I factor, I set each factor equal to 0, and I get my solution. So x is 3, and 2x plus 5 equals 0. 2x equals negative 5, and x equals negative 5 over 2. So those are my two solutions for this problem. When I go to number 6, notice that up until now they were all equal to 0, barring, like maybe like these that equaled x or something. But again, remember, it has to equal 0. And so what's going to happen is this right side has to be 0. So I'm going to have to subtract 3 from it. So I'm going to obviously have to subtract it from the other side as well. Remember, it has to stay balanced. So I'm going to get 2x squared plus 9x plus 4 equals 0. So now, again, I've got to think about my factors here. A is 2, so I know that my product has to be 2 times 4 is 8, and my sum has to be 9. So that's 8 and 1. So again, first term stays the same. Second term expands to 8x plus 1x, and the last term stays 4. Take the GCF of the first two. Take the GCF of the second two. And I know that that GCF is one factor, and what's left over, 2x plus 1, is the other. So all these steps were just to factor. Then again, I make my factors equal to 0, so x equals negative 4. That's one solution. And then 2x plus 1 is 0, 2x is negative 1, and x is negative 1 over 2. And again, two solutions to this problem. Now, when I come to 7 and 8, here again, you don't want to be tricked by the fact that it's an x squared equals an x, right? What you want to do is you want to bring this 3x over. So it's going to be 6x squared minus 3x equals 0. Then you want to factor your GCF out. So it's going to leave you with 2x minus 1 equals 0. And then we've got here, we set each one of these equal to 0. So 3x equals 0, which means x is 0. And then we've got 2x minus 1 equals 0, so 2x equals 1, and x equals a half. And again, there's my two solutions. So it becomes really easy and repetitive once you do enough problems, okay? So again, 8x squared minus 2x equals 0. Take out the GCF of 2x. I'm left with 4x minus 1 equals 0. So 2x equals 0. Divide both sides by 2, and I get x equals 0. And then 4x minus 1 equals 0. So 4x equals 1, and x equals 1/4. We keep going here. Again, same scenario. We have, again, a quadratic. Everything has to be on the same side, and everything has to be equal to 0. So everything on this right side I'm going to move over. And I always want my x squared to be positive. So I'm always going to get it on the side wherever it makes it positive. So x squared plus 6x plus 9 equals 0. And then again, I'm going to factor. This is x plus 3 times x plus 3 equals 0. And this means x plus 3 is 0, so x is negative 3. Obviously, if this is the same value, right, it's x plus 3, it's also going to be x equals negative 3. So you don't have to write negative 3 two times. Basically, what this means is that x equals negative 3. That is the one solution. However, it has what's called multiplicity. And multiplicity just means that it shows up more than one time, right? And when we get to graphing, I'll tell you what that means. If there's a difference when it shows up twice, when it shows up 3 times, it affects the graph. The intercept of this graph is still minus 3. So at, negative 3, 0 is where this graph is going to cross my x-axis. And again, I'll get into more details of that in the future when we get to the graphing section. But just know here's an example of a one solution problem. Okay, and then I keep going. And I see here I have 4x squared plus 12x plus 9. So I know that my product is 36 and my sum is 12. So this is a 6 and 6. So again, first term stays the same. The middle term expands to 6x and 6x. The last term stays the same, and it equals 0. Take the GCF of the first term, 2x plus 3. I take the GCF of the second term. I get 2x plus 3 again. And so that 2x plus 3 becomes one of my GCFs. It becomes one factor, right? And then I get a 2x plus 3 for the other one. And again, now that I've factored it successfully, I'm ready to solve. So I get 2x plus 3 equals 0, 2x equals negative 3, and x equals negative 3 over 2. Now, because this is the same, I know that I have this solution also again, negative 3 over 2. So again, my solution is just a single solution, negative 3 over 2. It does have multiplicity. It does show up twice, and it will end up affecting the graph when I go to graph it. But again, I'll show you that another day. Now, one thing I could have noticed is that this here was a 2x squared. This here is a 3 squared. And I noticed that this middle term is 2 times 2x times 3. And so I should have realized here that this was a special product. Okay, this was a perfect square trinomial, so it would have ended up being 2x plus 3 squared. So had I remembered that, I would have saved myself a little time and trouble with all this factoring. So again, just always keep those in mind. Number 11 is a little bit simpler to factor. This is an x minus 4 and an x plus 2. And my x equals, well, let me do it the right way. I'll do x minus 4 equals 0, so x is 4. And I'll do x plus 2 equals 0, so x is negative 2. And there's my solutions. Again, we just keep going with more and more examples. Now, if you notice here, my x is negative, so I don't like a negative x, squared rather. So I'm going to move it to the right to make it positive. So I'm going to end up with 0 on the left, and I'm going to end up with x squared minus 4x plus 3. And again, it doesn't matter what side the 0's on, right? I'm going to get x minus 3 and x minus 1. And again, I'm going to set each one of these equal to 0. So x is 3. And I'm going to get x is 1. And so there's my two solutions. So this one here in 13 is kind of weird. It has a fraction. But again, remember, we hate fractions, right? We don't want to work with them. We want to get rid of them anytime we can. And so remember what you learned, that if you multiply every term by the denominator, or if there's multiple denominators by the least common multiple, you're going to be able to get rid of the fraction. So if I multiply this first term by 8, the 8 at the bottom, and it'll cancel, so will this 8 here. And I'll just end up with 1x squared. If I multiply the minus x by 8, I get minus 8x. And if I multiply the minus 16 by 8, I'm going to get minus 128. Okay? And then now I have to factor this. And so this ends up being, notice that I just multiplied 16 times 8 to get 128. Notice that 16 times 8, if I do minus 16, and I do x plus 8, that's going to give me the minus 128 that I need, and it's going to give me the middle term of negative 8. So I was able to use these same two numbers here and here to actually factor. So x minus 16 equals 0. That means x equals 16. And x plus 8 is 0. That means x has to be negative 8. So these are, again, my two solutions, or the two intercepts of my graph. So what happens, is there a shortcut to factoring, or what happens if something's not factorable, right, or if you don't have all the parts? Well, one method that we use, and it's a really quick method, and if you can understand exactly when to use it, you're going to save a lot of time, is if you can take the square root of something. So you can solve using square roots. Okay, so let me just kind of give you and show you the examples. So right now, you know that this is x squared equals 15. Now what you notice is, notice you have no middle term here, right? This is when we kind of use this, when you have no middle term. And by middle term, in a quadratic equation, we're talking about the x scenario, where you don't have the basic x. In other words, in standard form, right, a quadratic equation is ax squared plus bx plus c. Well, this part is missing. And when this part is missing, you can solve using square root. So what happens is, notice, here's your ax squared, and this is kind of like your c value. It's just over on the other side, right? So what I could do is I could move it over, x squared minus 15 equals 0, and I could try to factor this, but what you're going to realize is you can't factor it, right? There's no perfect square for 15, and so you wouldn't be able to solve it that way. So let me move it back over to the right, and if I have x squared equals 15, if I take the square root of the left side and the square root of the right side, what's going to happen is the square root and the 2 here are going to cancel, and it's going to leave me with just x. So x equals the square root of 15. Now I have to remember one critical thing in that, and I usually write it right up here. When I insert a square root or an even root of any kind, it could be a square root, which is a second root, or a fourth root, or a sixth root, I always insert a plus minus, okay? And so I know that the solution to this problem is positive and negative square root of 15. That's going to be the answer there. Now, when I come over here, x squared equals 48. Again, I'm going to do the same thing, right? I'm going to write it out. I'm going to take the square root of the left and the positive and negative square root of the right. The left is going to become just x, and the right is plus minus square root of 48. Now I can simplify this a little bit because I know the square root of 48 is 16 times 3, and I know that the square root of 16 is 4. So this is the answer that I'm looking for. I have two solutions, positive and negative, 4 times the square root of 3. If I want to know exactly where that falls on the graph, I'll actually do the math and find what is 4 times the square root of 3. And that'll be it'll be something less than 8, and a positive and negative, but I'm not going to ask you to do that. So this is a perfect answer. Now, this scenario here is a little bit different. Notice that what you have here on the left, instead of just an x squared, you have this entire expression squared, and it equals 20. Now, you could technically rewrite this as 4x plus 1 times 4x plus 1 equals 20. You would have to FOIL this out. 16x squared plus 4x plus 4x plus 1 is 20. Then you'd have to come here and combine your like terms. Then you'd have to subtract 20 from both sides. And now you have to actually factor this to then start to solve. So this is a lot of work. I'm not even going to keep going, right? This is not the preferred way. I'm going to show you such an easy way to solve this. Now that you know how to use square roots, you're going to take the square root of the expression on the left and the square root of the expression on the right. And remember to do the plus minus on the right. So the left side is going to just be 4x plus 1 because the square root and the 2 will cancel. On the right, you're going to get plus minus square root of 20. Now, here I can, clean up a little bit the other side real quick. The plus minus square root of 20, I know the square root of 20 is 4 times 5, and I know that 4 has a square root of 2. So it simplifies to 2 radical 5. Now, I'm solving for x, so I've got to subtract 1 from both sides, and we do like to put it in front of the plus minus. So I'm going to get minus 1 plus or minus 2 radical 5, and over here I'm going to have 4x, and I'm going to divide both sides by 4. And so there's my legitimate final answer. X equals minus 1 plus or minus 2 square root of 5 over 4. So there's two solutions here. It's negative 1 plus 2 radical 5, that whole thing divided by 4, and negative 1 minus 2 radical 5 divided by 4. But that's your answer. And again, we'll do the very last one. And notice again, you're missing the middle term. So instead of trying to factor this, which is unfactorable, what you're going to do is you're going to get them on opposite sides. You're going to add 43 to both sides. And then you're going to take the square root of x squared and the positive and negative square root of 43. So x equals plus minus the square root of 43, whatever that number equals. So we're just going to keep going with other ones. Now, sometimes people with these x squareds that have a coefficient in front, they like to take the square root right there. I do not. I do not take the square root until it's fully isolated. So for me, I start by dividing by 9, and I get x squared equals 4. Now that the x squared is isolated, that's when I do the plus minus square root of the number on the other side. So I know the square root and the 2 cancel. So x equals plus minus square root of 4, which means x equals plus minus 2. That's my solution. 19, I'm going to start out by, again, isolating the variable there. I'm going to divide both sides by 25. So I'm going to get x squared equals 37 divided by 25. I'm going to take the square root of the left side, the plus minus square root on the right side, and I'm going to take the x, and I'm going to do, again over here, I have a denominator. My denominator does have a square root, but my numerator does not. So I'm going to do plus minus the square root of 37 over the square root of 25. And again, I know plus minus the square root of 37 over 5. So I had to kind of keep going because for a radical to be fully simplified, you cannot have a fraction in the radical, so this would not have been acceptable. And then if I had just done 37 over square root of 25, I can't also have a radical in the denominator, so I did have to simplify that as well. So last two on this page, the number 20, I take the square root of the expression plus minus the square root of the other side. This is going to leave me with x minus 5 equals plus or minus 5. And then I'm going to add 5 to both sides. Now again, we like to do that in the front. So 5 plus or minus 5. Now here, notice that I don't need a calculator for this, and so I can solve this. I can actually do the math out here, right? So I've got 5 plus 5, which is 10, and I've got 5 minus 5, which equals 0. So here are my two solutions, x equals 10 and x equals 0. So I don't mind you leaving it in radical form when it's not simplifiable, but if it's something you can add without a calculator and it's, you know, an integer like this, I definitely want you to solve it that way. And then lastly, again, square root of the expression plus minus the square root of the other side, and we get this cancels, so I'm going to get an x plus 9 equals plus minus the square root of 24. I'm going to subtract 9 from both sides. I'm going to get x equals minus 9 plus or minus the square root of 24. And again, the square root of 24 translates to 4 times 6, so I can simplify it a little bit better. Square root of 4 is 2, radical 6. And that's it. That's all I can do there. And again, we've got two more here. Again, on the left, I can take the square root and the plus minus root of the right side. The radical and the 2 cancel. I'm left with 4x plus 7 equals plus minus the square root of 44. I can subtract 7 from both sides, and I'm going to get 4x equals negative 7 plus or minus the square root, and I'm going to break this to 4 times 11, right? Now here, again, it's going to be 4x minus 7 plus or minus 2 radical 11, and then I can divide everything by 4. So x equals minus 7 plus or minus 2 radical 11 over 4. And this is a good final answer. Now, had, let's say, this number, notice that the 2 and the 4 share a factor. I could simplify to this and this to a half, but it only works, and we only want you to do it if both numbers are divisible by the same thing. So in other words, if this was maybe, let's say, a minus 8 plus or minus 2 radical 11 over 4, then you might have said, okay, I can take a 2 out of here, a 2 out of there, and a 2 out of here and simplify it a little bit. But everything would have to be factorable by the same thing. And since 7 is not, I don't want you to worry about simplifying it because you can't really do that as it is there, okay? So that's one thing. The second thing is somebody might say, well, why do I have to do plus minus when I do this? Now, let me just give you one that has a square root, okay? So what happens is if I just take the square root of 5 and the square root of 25 and I just do x equals 5, right? I'm going to get one solution here. But what we teach you is we say, well, you need to do plus minus. So if you do it the way we show you with that plus minus, then you're going to get that x equals positive and negative 5. And notice that it does. You know, when I'm looking for roots of 25, I know that 5 times 5 equals 25, but I also know that negative 5 times negative 5 equals positive 25. And so I know that when something is to an even root, like I multiply something by itself twice or 4 times or 6 times, negative numbers and positive numbers both give me a positive result. So I have to remember these negative numbers in my solutions. And that's why we do the plus minus. The plus part is you're gonna always find the positive answer, but this is a reminder that there's also a negative root involved. And this last problem that we're gonna do here, this last problem is actually one we're gonna skip. Okay, we're not gonna do this one now. If you look at it and you say, oh, what do I do? The correct setup would be to take the square root of the left and the positive and negative square root of the right. So what you're going to end up with is x plus 5 on the left, right, equals the positive and negative of x plus 4, okay? So again, that's the setup. However, we're not going to keep going and do this any further. We're going to stop right here, and we're going to leave it at that, okay? So this really isn't a problem that I want you worrying about. We're skipping this one for now. We'll get to problems like this in the future, but so far that's it. So again, you're going to learn to factor and solve by factoring, and then the other one is solving by using the square root method, which will save you time whenever you have the opportunity to use it.